Okay, so let's look at another example. Okay, for the domain and range here. Okay, so if you look at here, we have a fraction. Okay, we have the independent variable, which is x and y, and we have the dependent variable, which is z. Okay, all right. So if we look at here, fx. Okay, so if fxy equal to 1 over x plus y, is there any restriction? Okay, so the restriction is x plus y cannot equal to 0. Yes, okay, x plus y cannot equal to 0 because this is fraction. Okay, we cannot have the denominator equal to 0. If not, the graph will be undefined. Okay, so that's why from here we can state our domain. Okay, our domain subject to, okay, so this is our independent variable, okay, such that, okay, x plus y cannot equal to 0. That is the condition. Okay, that is our domain. Okay, so for the range, how about the range? Okay, so of course the range here, okay, so we know that it will be what in this case? Okay, so it is dependent variable z, okay, such that, okay, so for this case, can we have the value of 0? Okay, can we have the fraction of 0 here? It can be x plus y cannot equal to 0, meaning that x plus y can be positive, x plus y can be negative. Okay, can 1 over x plus y is equal to 0? Okay, no, right? So because we have here z equal to 1 over x plus y. Okay, so we know that the x plus y here cannot equal to 0. So meaning that it can be 1 over negative whatever, and then 1 over positive value. Okay, but it can be negative, it can be positive, it cannot be 0. So that is the range. Okay, so for this case, for the z cannot equal to 0. Okay, alright. Okay, so that is the answer. Okay, the domain and the range for z equal to 1 over x plus y. Okay, so now, before that, okay, so if you want to sketch the domain region for this one, okay, so the domain region meaning that we need to look at the restriction. Okay, we need to look at the restriction. Restriction is x plus y cannot equal to 0. Therefore, we need to sketch for y cannot equal to x. Okay, so x, y. Okay, so we know that the graph of okay, so y cannot equal to negative x, so we need to sketch this one. So it is negative slope. Okay, so it will be like this. Okay, alright, so it can be any number, okay, as long as it's not touch the line of y equal to negative x here. So the region can be here, okay, and can be here, but it doesn't touch the value on the line here. Okay, cannot equal to that one. Okay, alright. So for fxy equal to ln xy here, okay, so we need to determine the domain and the range of the f. Okay, so again we have the independent variable, which is x and y, and our dependent variable is the z. Okay, which is in terms of x and y there. Okay, so what is restriction for this fxy equal to ln x plus y here? Okay, what is the restriction? Okay, for the ln, we know that inside here must be greater than 0. Ln cannot be, the value inside the ln cannot negative. Okay. Alright, so therefore, in this case, we have the x plus y must greater than 0. Okay, so that will be our domain. Therefore, domain. Okay, so we have the variable x and y such that x plus y must be greater than 0. Okay, alright. Okay, how about the range? Okay, so if we choose the value x plus y must greater than 0. Okay, so the range for z here is what? So if you choose your calculator, if we push the calculator, okay, you can pick any value. So for example, ln 100, ln 10, ln 1, ln 1000. Okay, we can have the positive value. Okay, how about ln 001, ln 00001, ln 00002, for example. Okay, we will get the value of negative. So meaning that for the range, okay, it will be all real number. Okay, it can be from negative infinity until infinity. Okay, the value for the z here. So meaning that the range here for z is all real numbers. Okay, all real numbers. Okay, alright.